Just a reminder, please fill in the attendance form, which has been shared in the Teams. Yes. So be careful of the date and yeah, make sure you fill that in today. Okay. So today we're going to talk about you. So we're going to discuss module 4. And in module 4, you have the important topics of IPv4, IPv6 addressing. And with addressing comes subnet addresses and node addresses and node um, points and how you address them. So that is all what we're going to see. We're going to try and solve a few questions in this session. In this, as many as we can do. Okay, let's wait. So the first before I start, I want to say the important thing that you have to know is how to differentiate between an IPv4 and an IPv6 address. Because when you see question, you need to know whether it's IPv4 or IPv6, otherwise you not know how to take the subnets, how much bits to assign, right? So let me give you two addresses, 1234 ABCD CDE4 and so 3141. This address and another one 127.0.0.1. So whenever you see the idea is whenever you see hexadecimal digits, like here you have A and B and all these kind of things, that should tell you that it's an IPv6 address. And the normal, this 127.0.0.1, this is more like a normal IP address that you would see. This is an IPv4. So so now you should know how to differentiate between IPv6 and IPv4 just by seeing the address. And the important thing to note is IPv6 means you're given 128 bits of space to write the address. And IPv4, you're given 32 bits. 32 bits of space to fill in your address. Uh, Another thing you have to remember is these bits. So let me write it here. So we say bits is binary. You cannot count these decimal values and say how many bits, or these hexadecimal values and you can see how many bits. So if you have decimal value, if you have decimal, you have to convert that into binary before you can count how many bits there. If you have hexadecimal, so one hexadecimal bit, the coding is made in such a way that one hexadecimal bit is 4 binary bits. So let's just verify. Here you can see how many. 4, 8, 12, 16. 16 in total here in this. So it's and so 16 into 4, 64. That's how many are represented in just this much. So you're missing so an actual IPv6 address would have these many more. This is a full IPv6 address where you have 4, 12, wait, 4, 8, 12, 16. Yeah, 4, 8, 12, 16, 20, 24, 28, 32. Yeah, 32 into 4 will give you 128 bits. And so that this is how IPv6. So this is the if you have this straight, all the questions will become much easier. IPv6, this is what it looks like, 128 bits. IPv4, this is what it looks like, 32 bits. Okay. So this was intro. Now let's look at a question. Question one. Mm, okay. A host has an address and an address is given. If node identification is 48 bits, find the address of subnet to which the host is attached. So first thing when you see this address, you know it's IPv6, right? And so it should have a total of 128 bits, right? So and you can see they've given us 4, 8, 12, 16 of the first bits. They put this double column, which you should know is zero compression, and they've given the last 4 digits. So how would you write this in total? How will you write this in full? 581E 1456 2314 ABCD something 1211. How many zeros would you need until you reach 32? Yeah, so 32 into 4 will be 128. So let's have 000 000 000. And I think we have reached 4, 8, 12, 16, 20, 24, 28, 32. So this is the full IPv6 address that we have here. And the good thing about this is that you don't have to convert into binary if you're doing IPv6. Okay, next we're given that the node identification is 48 bits. So 48, 48 binary bits. How many bits is this in hexadecimal? It will be 48 divided by 4. So this in binary 12 in hex. Right? So because 12 was, you get 48. So that means this last bit, these last 12 bits, this is node. Right? And then you have node. So you should know an address is made out of subnet part and the node part. So once you know how much is the node, this much is the subnet, the subnet part of the address. Now the question here says, find the address of the subnet. So typically what happens in IPv6 is, let me write it here, you have the prefix. So this is for the subnet. The S that gives is a prefix and a subnet identifier. And usually subnet identifier is 32 bits. And how much is the prefix would be dependent on how much space you have for the subnet. So we need to find, so when they ask what is the address of subnet, they're asking for the identifier of the subnet. So you need to take 32 bits. 32 bits in binary, hex when you do it, it will be 8 hexadecimal digits. So this is the prefix, the one before it, the 581 all the way to 2314. Then the last 8 bits, ABCD and 0000. This is your identifier. And that is your answer. That is what they're looking for in this question. So they gave us an address, they gave us the node identification, 48 bits or 12 in hex. We found how much is the node, we have found how much is the subnet. Then they're asking for find the address of the subnet to which the host is attached. That means they want the identifier without the prefix. Identifier is typically 32 bits, which is 8 in hex, and we have taken those 8 bits from the submit part. So that is the answer. Okay. Let's see another question. This is again IPv6. We can see from the address, and it's also given IPv6. Okay. You're given 200 subnets, class B address of this. So this is an IPv4. The site recently moved to IPv6 with this much, with this address. Design the subnets and define subnet addresses using subnet identifier of 32 bits. Okay. First thing, since it's IPv4, IPv6, sorry, we write the whole thing. So 81E, E1456, 2314, something, ABCD. And so we need to fill. So we're given the prefix is given as /80. What does /80 means? So when you have a prefix that is given as /80, this means that the total for that prefix, so I'm going to write prefix will be 80 bits. Yeah. So we have to get this to 80. Currently it is 4, 12, 16, 20. So how many more do we need to put? So 80 in binary. So we'll write 80 in binary, which is divided by 4, 20 in hex. So how many do we need to make this 20 in hex? We have 4, 12, 16, 20. 20. Oh, okay. Yeah. So so 4, 12, 16, 4, 8, 12, sorry, 4, 8, 12, 16, 20. Yeah. This is how much you get. This is the prefix. Sorry. Yeah. This much is the prefix. And what will you have after this? The remaining part of the address. So you need to get to 128 bits or 32. So 0, 0, 0, 0, 0, 0, 0. So let's just mark this much is given as prefix. We have this much remaining, right? Now we're saying design the subnets and define subnet addresses using a subnet identifier as 32 bits. So they're asking us, so this is, we can see this is 4, 8, 12, 12 into 4, 48. So this is 48, so 32 would be this much. This much is identified, right? I can actually remove the top. 32 bits identified. Why 32 is written in the question. 32, when we convert to hex, it will be 8 bits we have taken. So what is remaining now? This much. That will be your nodes. So in the previous question we saw, you had so this S is actually your prefix part, that's an identifier part, and after that whatever is there remaining is the node. So you have the prefix part, identifier part, remaining is the node. Right. So to identify the addresses, you would need to change this, right? And how many addresses would you need? So you need 200 subnets. So would one of these bits be enough? 2 raised to 1, that will already give you uh, 2. It's not 2, it's inside it's 4, right? So we're using, if we use all these 4 bits, so 4, if you're using only 1 bit, it will be 4 raised to 1. If this isn't binary, you would do 2 raised to 1, but it's not binary, it's hex. 4 raised to 1, 4, not enough because we need 200. You'll do 4 raised to 2, 4 raised to 3, and finally when you do 4 raised to 4, you'll get 256. 256. So that's why you need to use all these nodes. And it's sufficient. So your final answer will be this whole thing. From here, you have to do till. So we'll write from here to you'll have to do till 200. Or you can write it in a so not won't be 200, it will be 200 hexadecimal. The hexadecimal value of 200. Let's say it's DEF1, so it will be that, it will be till that. Or in general, if you want to write in general, it will be, so this is the general presentation. Just replace this with xxxx. So x is a variable which can be either 0 or any number, whatever. That is this question. So they gave us the address, we expanded it fully. We marked how much was the prefix. So they said 80, we marked that much. They said how much is identified here. They said 32 is identified. We marked that. Remaining was node. We found that the node is enough because it has 4 bits. That will give us 256 space. We need only 200. We were able to convert that to hex and show the general format. Okay, let's do an IPv4 question. ISP is granted a block of SS starting with this address. So when you see the address, you should know we are talking about IPv4. The ISP wants to distribute these blocks to 100 organizations, with each organization receiving just 8 addresses. Design the subblocks and give the slash notation for each subblock. Find how many addresses are still available. Okay. So when you have IPv4, the first thing you want to do is convert this into binary. So let me find out what is the binary. So for 120, so this is 20. Using your calculator, you can find out binary is 1, 2, 3. 60 in binary. 0, 0, 1, 1, 1, 1, 0, 0. Okay. 4, we know it's going to be 0, 0, 0, 0, 1, 0, 0. Do we have 8? Do you have an extra? Yeah, okay. 22 is the prefix. So putting this all together, our full address. So in IPv6 also we have to write the full address. Here you write the full address, but in binary, it's going to be 0, 1, 1, 1, 1, 0, 0, 0 dot 0, 0, 1, 1, 1, 1, 0, 0. And then for 4, you have 5, 1, and then you have again 0. 2, 3, 4. Okay, so this is the full. You should have total 32. Why 32? Because it's IPv4. IPv4. Okay. Now you're given the address. Now you have to calculate. Now you're given the prefix 22. 22 is the prefix. So the first 22 bits from here will be the prefix. So prefix. So the way how they do this is they write 122 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. You could do this, you don't have to do this, but you should know that this much amount is taken for prefix. Let me put it again. This much is taken as prefix. Okay. Now, how many bits do we need to represent everything? Right, we're given 100 organizations, each with 8 addresses. So total we're looking at the total addresses, total number of addresses, simply 100 times 8, 800. We have 800 addresses. Now, how many bits do we need to do? So here you want, for bits you want to 4, instead you'll do, so you do 4, that's wrong. So hex, instead we have to do 2. So how many will be enough? So we know that 2 raised 4, 16, that's not enough. 2 raised to 10, 1024, about 2 raised to 9, 500. So we need 10 bits, right? We need 10 bits in order if you want to represent 800. You're actually going to get more because this can 10 bits can represent 1024 and we need 800. But if you take 9 bits, 512, that's too less. So 10 bits. Okay. How many 10 bits? 2, 4, 6, 8, 10. We need these 10 bits to represent 1800. But how much is 800 in binary? 800 is going to be 1, 1. Let me type it. 1, 1, 0, 0, 1, 1, 3, 4, 5. That's how many in binary. Right. So we can start giving the addresses. So do we have a total of 30? We have 10. We have 22. Okay. So each one has to get 8 addresses. So the first address is going to be this. So first person will get from this to this entire thing till 8. So that's going to be 1, 1, 1. No, no, no. 1, 0, 0. Or we can write this in simpler forms. It will be 127. In decimal form, 127, 60, 4, 0 to 127, 60, 4, 8. Right? So it will be the next one. We need next 8 addresses. So this is one organization, I think. One block, one organization. So this is one block. So they need 8 addresses, and in that block, 8 addresses are. The second one will be 127, 64, 8. Oh, so it won't be 8. So 0 to 7 is 8. And then we'll start from 8 to the next one. 2, 127, 64. How much? 15. Right? So you will go on like this. So the next will be from 15 till 8, 3 is 24. So this will be 23. 16 to 23. And that's how you'll go on. You don't have to write everything, but you can write how much. So one thing they asked is design the subblocks and keep the slash notation for each subblock. That we have not done. We have just given the address like this and now no slash notation. So how to convert to slash notation? How to convert to slash? And slash means here we're talking about the prefix. Slash is prefix. How much can you assign for prefix in this? So let's say we are 8, the one that changes 7, that's what we represented here. Also 7 is going to be 0, 1, 1, 1, right? So how much we change from 0 to 7, that is represented by these 3 bits. What is the remaining? How many? 8, 16, 24, 25, 26, 27, 28, 29. That is your answer. So to convert this to slash, just write the same thing from 127, 60, 4, 0, prefix 29 to 127, 64, 7, prefix 29. That's it. Right? So let's look at everything again. We were given an address. We given the total number. So first we saw the address. We found it. We know it's IPv4. We know that there's total of 32 bits. We expanded it full address. Next information we got is they gave us the prefix. We put the prefix. We found out how much is the prefix and how much we are allowed to use to make our network. So the remaining. Okay. Then what did we do? So we found out that we had 10 bits, and 10 bits is enough for us to represent 800. So that's verified. Now we have to start giving. Each block has 8 addresses. And so first block we gave it 8 addresses from 0 to 7, and from 8 to 15. Then it will go 16.3 and we'll go on. Then they ask give the slash notation for each subblock. This is how we give the slash notation. This. And okay, and one more thing is that find out how many addresses are still available after these allocations. So how many available? And this is very simple to find out. How many bits are we given? 10 bits. And with that, how many addresses could we represent? 1024. So total we had total wait, available. Total was 1024. How many are we using? We saw we only need 100 into 8, 800. So we're using 800. That's it. So available will be 1024 minus 800. That is 224. That is your answer. So Available addresses is easy to find. How many bits do you have in total? How much can you put total? How much will you put? 800. And available remaining will be 224. Yeah. So we saw an IPv4. Need to remember to convert to binary. Prefixes, the rest node identifier, how many bits, how to write the blocks, how to add slash notation. So you would have to write slash notation for everything. So this would be 127.64.8 slash 20. It will be 29, right? Okay. Yeah, it will be so you have 32 and you've taken you're using the last three bits to get from 4 to 7, and that prefix will remain for all the subblocks that you put. So the next one would still be 29. And so you would have to continue writing from 127 64.8 slash 29 to 127 64, what is it, 15 29. Right? Because slash notation is not for an address. Slash notation, what it denotes, slash is going to be for the full block. And in a particular block, you only need 8 bits to change. You need 8 addresses. So only 3 bits are going to change. That's why the slash prefix will remain same for everything. So we saw slash notation and how many available. Yeah. Okay. That's all that I wanted to cover in this questions. Basically, you might be asked subnetting questions, and you may be given um, how many subnets, what is the start address, what is the end, or or you can find in the middle. So let's see one last question about starting and ending, since I've mentioned it. I think there is a question here. What is the first address? So you're given an address. Quickly, let me do. You're given an address. What is this first and what is the last? So it's very simple. First is equal to address times prefix. Last is equal to address times x prefix inverse. Let me. So what you will do is you have 25, 34. You have 25, 25, 34, 34, 12, 56. And what is the prefix? Prefix is 16. So 16 means you're going to have the first, you're going to have the first part filled all ones. You're going to have the second part filled all ones. So that's 8. The 8 bits, total 16. So when you can convert this to binary and check, and then put 16 ones, 1 until you get to 16. But when you convert it back, you will get 256, 256, 256, 0, 0. And then when you multiply this in binary, you can try it. You're going to get 25, 34, and then 0 will be 0, 0. And for last prefix, you have to take the inverse. So in inverse, what are you going to do? You have 25, 34, 12, 56. Inverse of 256 to 5600 would be 0, 0, 256, 256. And here you will get, oh, I've made it. It's not into, it's plus, plus prefix inverse. Here you'll get 225, 34, 256, 256. But I think, so this is, wait, so this is a plus, this is a multiplication. So if you're wondering how we are able to multiply these two and get this, convert into binary. Convert into binary, if you have 1 and 0, it will multiply. You multiply these two and you'll get 0. If you have, so let's say you have 0, 1 times 1, 0. You multiply 1 and 0 and get 0. You multiply 0 and 1, and this will also be 0. If you have 1 and 1, and you multiply, it will be 1. The same way that we do. In addition, it's not actually addition, so it's like your the union. So like it's like 1 plus 0, and even the vice versa will give you 1, and 1 and 1 is also going to give you 1. So let me make that clear. So this is and, yeah, and is the correct term, and this is or. So it's not the normal plus and minus, it's the and or. So when you do convert this to binary, you'll be able to get these answers. You can check this. Okay, I think that's all the time that we have for today. We Yeah, so we'll see in the next session. I'm going to stop